All right. Good morning, good afternoon, or good evening, wherever you are. Welcome in this new webinar. Today, I hope everything with the sound is okay, the video is okay. Just give me a short sign in the chat box if everything is clear on your side. Sound and video are okay, I hear. So that means that we are all ready to start exploring what we have available for you in the FNC Cloud Pack. Invitation to stay until the end of this webinar, because as always, we have something for you at the end of the webinar. So what's the goal for today's webinar? That we will see first. We will discuss the goal of the webinar, architecture of our components, an overview of our components, and I think the most interesting part will be looking at a couple of examples that show you how you can use these FNC components in real life projects. So what's the goal of what we do within the scope of the FNC Cloud Pack? We want to make a set of Object Pascal components available for you that allow you to seamlessly access various cloud services, a number of public-facing cloud services that are available for you, as well as any custom cloud services that you might have an interest in using. And the main idea here is to make your life as easy as possible and to avoid that you have to go through the learning curve, the same learning curve as we went through, of course, making these components, the learning curve of all the different APIs of different cloud services that exist. And this is all wrapped for you in easy to use Object Pascal classes. And with these public services comes also an important part, which is the authentication and authorization. And most of the public-facing REST API services have standardized on the OAuth mechanism. And of course, that's an important part and a part that is handled for you in the FNC Cloud components. When we talk about authorization and authentication, there are two very important parts when you would be on the other side, the side of the people who are making such a REST API service available. That is to control who can access your service, who can do what in this service. If, for example, you would have an interest, which is not in the scope of this webinar, but if you would have an interest in creating REST API services yourself, that is something that our Xdata product is doing for you. It allows you from Delphi code to create these REST API services. And there, of course, you will also have to do with controlling who can do what with my service. You obviously do not want people with no authorization to do any malfunctions on your service. So security is an important part, and that is handled. OAuth is one of the things that handles this security perspective, but there are a couple of other things as well that help in the process of ensuring that only users who are permitted to do something can actually do something. And so one of the mechanisms implemented for controlling the security is the OAuth flow. That is the flow that, first of all, performs the authentication and performs the authorization, authorizes someone to perform REST API calls to your service. In the OAuth, the actual purpose of the OAuth flow is to avoid that you have to pass any username password combinations to the service yourself. That actually dealing with username passwords is handled by the service and is as such not handled by the code that consumes this service. That means that you will only enter your username and password via the service itself, and your application consuming this service will actually never see that username and password. So the username and password remains something strictly related, confidentially stored within the service itself. And the technique used here is in the OAuth flow, that the first thing that happens is showing the login service of the REST API service itself, showing the login. So you're actually entering a screen provided by the service provided by the REST API server itself. There, at that point, you enter your username and your password. And upon validation, that causes a callback to go to your application. And from your application, then there is a mechanism so that you receive an access token. And the access token can include several permissions to do specific functions, to call specific APIs on the REST API server. And so the flow, if you want to look at it in detail, is here on that diagram. So the first part is redirecting to a login screen of your service login, entering your username and password, receiving via a callback an authorization code. With that authorization code, actually includes also a secret code with that authorization code that results in an access token that is returned from the service. And the access token is some encrypted token, typically a very long encrypted string that is used with every subsequent REST API request that you will do to the service. And the server checks that access token. It has actually handed out this access token itself to your application, so it can validate for each request if that access token is valid or not. Typically, also a access token has a limited lifetime, and that means that you might have to renew that access token every so many times. Typically, this is like 3,600 minutes. That's a standard value, typically commonly used for access tokens. And every so many minutes, you need to renew it. That's to ensure that if in some way whatsoever someone obtained that access token, that he will not have eternal access, unpermitted access to the REST API service. Another common implementation for security is CORS, typically referred to as CORS, Cross-Origin Resource Sharing. That's what these four letters stands for. And that is typically in connection to consuming REST API services from a web client. Suppose that you have a web application that is using a REST API to get to the data that goes with that web application. Then CORS will ensure that the REST API is only accessible from your website, from your web pages. And that someone who is crafting other JavaScript code and puts that onto another domain, another server, that from that other domain, that other server, the REST API calls will be blocked, and only when the JavaScript code is executed from your domain that the REST API calls will be permitted. And is implemented, therefore, is a technique in the browser itself, the browser that runs your web application. And the first part of the HTTP request to your API server is actually a kind of notification that the request is coming from your domain. It's only when that request is coming actually from an allowed domain that the request will be responded to. Otherwise, your browser will just get a notification that this access is not permitted. And so that is another important, frequently used mechanism for security in REST API calls, in particular from web applications. If you develop an application, a web client in TMS Web Core, and your service, your own service or another service does not permit access to come from other domains, that is typically the coarse error that you will see. And I strongly advise to watch your browser console if this happens to see the details. So in a nutshell, given or taking these security concerns in account, this is actually a list of all the needed functionality that we will typically encounter when we want to consume REST APIs from Object Pascal code, from your Delphi applications, etc. So we'll deal with authentication and authorization, typically through a OAuth flow. We'll deal with the application key and secret, and that is typically the keys, the client IDs that are handed out by the REST API server to uniquely identify who is consuming that service. And the set of permissions there are that are allowed to consume are typically defined or set in scopes. So the scopes define what areas of the REST API will be accessible to your application. Everything with REST API servers happens through HTTP requests. So obviously, our library will support all the typical HTTP requests that exist: the get, the put, the post, the insert, also the delete, the patch, etc. Also, some typically used cryptography functions are available within our set of components, and these are typical encryption standards, like, for example, those used in the OAuth flow that are part of the classes that we have here bundled for accessing REST APIs. We talked about HTTP requests, and typically with REST APIs, the data format over which the HTTP request will send and receive data is the JSON format. So it's kind of obvious too that there is also coverage to help you with deciphering or decoding the JSON that the REST API server returns. Then some more typically in REST APIs used functionality, and that is date encoding. I'm thinking here about the ISO date formats, which are the de facto standards for encoding date and time. Also typically used for sending and receiving binary data is the base64 encoding. That is also, there is also built-in support for that. And URL encoding, if you have URL requests with specific characters that are not directly supported in a URL, but still need to be encoded, that is also provided. Token storage, so I talked in a moment about access tokens, for example. You will typically, once you received an access token, typically want to persist that for future usage. Refresh token is also something that might be convenient to store. And so this token persistence is also part of our library. And finally, a big difference between asynchronous and synchronous operations. In our cloud components, we allow you to choose whether you want an asynchronous model versus a synchronous model. Basically, this means that if you opt, and we recommend actually to use the asynchronous mode, that you will never get any blocking calls in your application. And with blocking calls, typical phenomenons like freezing of your screen, non-operational applications for at least some small or even larger amount of time, that is all avoided when you use an asynchronous model. Of course, for your programming flow, there might be instances that you have a preference for a synchronous model. So synchronous mode is available, asynchronous mode is recommended. And another goal of our FNC Cloud Component Library was, of course, that it will run everywhere where you can use Object Pascal code. And that means nowadays that you can use this in VCL applications, in FireMonkey cross-platform applications, in Lazarus, and these use the LCL framework, and also in web clients created with TMS Web Core. That's why we created the FNC abstraction layer. All our FNC Cloud components and FNC Cloud base classes are developed against this abstraction layer. That means that if you have an FNC Cloud component, you can use it seamlessly and with exactly the same code with all of these frameworks. And so that results in the fact that our FNC Cloud components, they are offered via one code base that you can use in all these different frameworks. Of course, as you use the same code for different frameworks, that means that there's also only one learning curve for you. Once you know how to use these cloud components, you can use them in different applications, and it does not matter whether it's the same or a different framework. And an extra convenience is, of course, also that this comes with only one license. So one license gives you the possibility to create applications for all these different targets and all these different platforms. Targets, as I mentioned, VCL, Windows applications, Win32, Win64, FireMonkey applications for iOS, Android, Linux, macOS, web core applications running in a browser, and that will be any modern browsers these days. And as a final bonus with Lazarus, you can also create applications for the Raspberry Pi OS operating system. So also using this in small IoT applications, it is possible with the FNC Cloud components. In terms of IDEs that are supported, these are the different IDEs where you can install the FNC Cloud components in and you run them from, use them from. That is Delphi, of course, first and foremost, the Delphi IDE, also the C++ Builder IDE. You can use them from Lazarus, and noteworthy here is that Lazarus IDE itself can run on Windows, on Mac, and on Linux. So that means that you can develop with our cloud components from these three different operating systems. And to be fully correct, Lazarus can also be used from the Raspberry Pi OS. So that's a fourth operating system from where you can use our cloud components. And finally, there is also Visual Studio Code with which you can create TMS Web Core web client applications. And Visual Studio Code itself is free. That's a convenient thing. And it can also run on 3 different operating systems. It can run on Windows, Mac, and Linux. Let's have a short moment now to dive into the base classes, because the knowledge of the base classes that are there for you to use will help you, of course, tremendously getting started. One of the base classes is the class that covers the HTTP request itself. That is the representation of HTTP calls to your REST API servers. And here are a couple, or the set of properties that are available to you. Typically, you will perform the HTTP request and you specify the server, the host, the port, and the query string. Also the HTTP method. This is where you will specify get, put, post, insert, delete, patch, etc. You can also specify what kind of result type you expect. Will this be a binary result or a string-based result? And also important are headers, HTTP request headers. It is, for example, via a header that, but the component will take care of that itself via a header that you will pass along your access tokens. And that is the access token with which your requests will be either accepted or not. So these are properties available for you to specify how you want HTTP requests to be performed. And when the server responds, it will return this response via the cloud-based request result class. And here you can read whatever information the server answered. And that is, for example, how long the result was. That is also the result as text or the result in binary format. And the server can, for example, also communicate back several other things via headers. So the response headers can also be checked from this class. If we post data to a server, there are typically in REST APIs various ways to post data, and it can quickly get quite difficult to make sure that the way that you post data, that way is in the accepted format by the server. One of the things, for example, is that when you want to send data to the REST API call or endpoint, that this is in a multi-form format. That is a format where you will specify different name value pairs in a multi-form format that requires some specific coding. And we have made it easy for you to ensure that if you need to post data into a specific format to the REST API endpoint, that the post data builder will build the post data in the correct way for the server. So as you can see, you can specify here the type of how you want to submit the form data, and you can add here part per part to that form data. That is what the post data builder will do for you. And everything is bundled. These helper classes are bundled for you in the custom cloud base class. That is the base class from where you can do requests, from where you can build the post data, from where you can get the result back. You can see here at the bottom the property request, that is for performing a single request, and where you will get the result via the request result. But this component also enables you to queue different requests, and that's where you can perform, for example, add request, multiple add request calls, and then execute all queued requests at once in the execute all requests method. And with this base class and helper classes, we have meanwhile exposed various cloud services, public-facing cloud services that you can consume from your Delphi or Lazarus or C++ builder applications. And so this is a brief overview of these popular services, but I have also mentioned these by category or by type. So first, frequently used cloud service is a cloud service for storage of files. And 4 such popular services are Google Drive, Microsoft OneDrive, Dropbox, and also Box. PIM, Personal Information Management, offered by Google Calendar, Google Contacts, Google Tasks, also Microsoft Calendar and Microsoft Contacts. These are all covered out of the box. Cloud data, that is not file storage on a cloud server, but data storage. And popular services for this is Google Firebase, our own service, My Cloud Data, and also the Apple Cloud Kit. File format conversions. Also, different services exist for this specific purpose. For example, video format changes, changes in audio format, picture file formats, etc. And we cover at this moment 3 different services for that: Convert.io, Zamzar, and Cloud Convert. Mailing functionality, sending emails in an automated way are possible via different services. Here we cover Google Mail, Microsoft Outlook, MailChimp, and the SendGrid service. Logging, if you want to add cloud-based logging to your applications of what kind soever, we cover you with the Sentry service, Rollbar, and also Exceptionless. Also, SMS sending is something that is covered. We have Twilio, Bulk SMS, InfoBip, and Spring service. And a nice thing here is that with just one property switch, you switch the service. That means that you can code your application for sending SMS once. And if you simply want to change to another SMS service, that's just a property switch away. And then, of course, there is the FNC Cloud base class that can be used to consume just any cloud service. And for that, we have our REST client component with the REST client editor. The purpose of the REST client editor is to make it easy for you to play with, test HTTP calls to your REST API server, and see already either at design time or with our separate REST Insight application to see that the server is responding what you expect, first of all, so that you are sure that all your settings for your HTTP requests are correct. And on top of that, we'll see that in a moment, also offer you to generate all ready-to-use Delphi code for consuming the responses from your REST server, so that you do not have to go to that typical cycle of creating your application, setting up your component, your REST client component, compiling, running your application, observing what the answer is from the REST API server, and adapt if necessary and go through the same cycle again and again and again. Now, with our REST client editor, you can do all of this at design time, verify the results. When you're happy with the results, then it simply stores your latest settings into that REST client component. And so you're sure that when the first time you run your application with the REST client set up as is, it will work as expected. It will return the expected result to your application. And that was enough of a presentation. I think now comes the part where we will go in our Delphi IDE, and we will explore some of these functions. And the first thing I wanted to cover with you is the REST client. So let's have a look at our REST client demo. And I have this on my machine. Let's have a look. Here is the demo. So what we actually did in this demo is quite simple. Okay, here it is. We dropped a REST client component on the form. And as you can see, it exposes the property to control or to set the request that you want to perform. And it is actually by double clicking. No, sorry, it's by the context menu. From the context menu, I see that I missed here a part in the setup of the latest version. Let me see if I can correct it. I updated today to the latest version of the FNC components, and apparently it did not pick up the right things. So let me have a look if I can bring up our REST Insight application from here. I'm looking on the other drive here. Okay. And here I have the standalone REST Insight application, which the positive thing here is that it also gives me the capability to show you our REST Insight, which is a standalone application. So even if you do not have Delphi installed, you can play with your REST API server or a public REST API server and test all the requests. And so here in this example, and let me bring up a browser to show you that. We have a static endpoint, an easy to use static endpoint. So that is the URL for our endpoint. And as you can see, here it brings up this response, and it's initializing all kinds of extensions here in my browser. Here we have an array of JSON data. Okay, so this is the response for this specific static endpoint. And let's now see how we can use the REST editor, the REST client editor, to see the result. Either it's in the IDE at design time, and here you can see I tested, this is the endpoint URL, I did a send, and you see the response. One of the first nice things here is that we see the response with a nicely formatted JSON. Some specific details like how much time it took, what the total size is of our response. Here we can see the response headers that our server returned. And this here is the nicest part of the REST client editor, which is generated code for the JSON that is returned. So you can see that we have a JSON array with a JSON object, and that is such an object. So the REST client editor detected these JSON classes, and it has generated an items class with properties that match what it found in the JSON. And this is the object class in the JSON. And here you can see that it also detected that it is exposed as an array. And that array is exposed here as a generic list of these items, and the class it generated, the class name it generated for that is the MyDelphi class, to be altered, of course, if you want to have this in your application. But this is actually here the unit 3. I copy and pasted this code here in unit 3, and I used this unit 3 in my test code. So you can see that I have my reference to this generated code from the REST client editor. And so the only thing that I need to do is execute that request. So the REST client editor did set all the properties right according to what I specified in this editor here. Here you can see that I didn't need to set any header, etc. I specified that it is a get command and the URL. That was mostly it. And it configured these properties correct. So if I do the execute requests, here we are assuming that we will use this component in an asynchronous way. That means that when I execute this request, when I get a response, the event on request response retrieved will be triggered. And if we go and have a look into the code for this response, so again, this event will be triggered asynchronously, depends on the time your server needs to return that response. And what I do here is I create an instance of TMyDelphi class. That is the class that the REST client editor suggested. And what I do is I retrieve this, the actual data in this class. I retrieve this from JSON, the result string, the JSON string that is returned by our endpoint. And here what I do is return how many items are in this JSON. And then I will simply fill my grid with a couple of properties of the items in my array. So let's run this application. And let's have a look. Okay, so here I click on execute. I see in a message box the JSON response from my server. I click OK, and it informs that there are 99 items in my JSON array. And now it will simply loop over all the items in the JSON array and fill the grid with these results. So that's the purpose. Allow you to play with your endpoint at design time and have that helper tool generate as much as is possible for you, generate the Delphi code that you can use to deal with the JSON responses from this server. Let's move on to a next cloud service, which is the Google Calendar example. So here I have my application with a Google Cloud Calendar component. And I have something else. Google obviously uses authentication and authorization. And for authentication and authorization, it requires that you have an API key. If we look at the component properties under authentication, you can see here that there are several properties where you can set, in this case, your key, but for some other services, it's also important to specify the callback URL, the client ID, etc. This is what typically deals or is concerned with the authentication part. In this case, I need the Google API key. That's a personal key, so it's very important that this key stays personal. That's why I have here a little helper tool that will just put the key in my clipboard, and I can paste this in an edit control that has password characters set. And if you have a look at the code, you can see here that I will be setting my authentication to this, the content of my edit control. And in a first step, what I do is once this is set, I call authenticate. Authenticate will start the OAuth flow. In this case, with Google, this is the OAuth 2 flow. So you will see the Google authentication screen, and it is expected to enter your credentials there. And if you entered your credentials, it will return that the authentication was successful. And here you can see the event unauthenticated. Again, this is also an asynchronous behavior, because you don't actually know how long the user will take to enter his credentials in the browser, for example. So that's why whenever the user completed the authentication on the login screen from Google, when that was successful, the unauthenticated event will be triggered. In the unauthenticated event, the Google Cloud component itself has obtained the access token. It manages the access token itself, and it will actually use that access token for any subsequent call to the REST API from Google. So what we do from here is simple. We give a response that the authentication was successful, and the first thing we do is the get calendars call. Let me show you why we do a get calendars call. I prepared here access to the Google Calendar. So this is my Google Calendar. And as you can see, it has 6 different calendars. So a personal calendar here, and also a company-related calendar, for example, also for our marketing purposes, etc., for keeping birthdays. So in total, it has 6 calendars, and Google Calendar allows you to operate on each of these calendars. So the first thing to do is get access to all the calendars that Google Calendar provides. And also here, we implemented this in an asynchronous way. So irrespective of the response time of Google Calendar, it will return on get calendars when it has retrieved all the information for your calendars. So the first thing it does is show you how many calendars did I find, and it will fill my list box with the identifiers of the calendars. So the calendars all come with the unique identifier, calendars.id, and also a calendar description. So the description is obviously what you will see here. The names here in this calendar, the IDs are unique IDs that identify the calendar. When I want to get information from a specific calendar, I will need to use that ID. And actually, that is happening when I will select a calendar. Let me bring back the user interface. And so I will list the available calendars in this list box. When I click one of these calendars, what I do is extract the unique ID, this calendar ID, and get the actual calendar information from that specific selected calendar. Here, I'm getting all the events in this particular calendar for the next 10 days. So from now to now plus 10 to the next 10 days, it will retrieve this information. And also here, it will receive this information asynchronously, and that information is retrieved from the onGetCalendar event, where I will show how many items it retrieved and fill up the second list box with the items found in that specific calendar. Also, the items in the calendar have a unique ID and have a summary, the text, the title text, so to speak, from the items in your calendar. So let's start. No, that's not, that application was already started. I need to start this Google Calendar example. Here, all the demos are based on VCL, just to make it easy, fast, convenient, but I could have used the same code and everything the same in a FireMonkey application targeting macOS, for example. So all that is possible. That I don't need anymore. Where is my key manager? Here is my key manager. So what I do is paste the authentication key from or the API key, sorry, for the Google service here in my edit control, and I trigger the authenticate. And so here I'm now getting the Google. I'm at an URL HTTPS from Google. It already signed in because Google persisted my credentials with the browser itself. So I can choose an already signed in account here. That's my personal account. And now we get a screen that Google has not verified my application yet. So when you create an application with Google, you can start using it right away. But to bypass this screen, you need to have Google verify your application. That's a process to let Google know details about your application. It will check it, approve it, if you're doing, if everything is properly. We can bypass it by here selecting to proceed anyway. And here you see, and here we talk about the scopes. So here we have set in scopes of the request that we did that we want to edit, share, and delete calendars from your Google Calendar. And we will allow that if we click from here. And as you can see, it says that my application was authenticated and authorized. And that means that I got the authenticated event in my application. I have as such the access token, and now it was able to retrieve the 6 calendars in my Google Calendar account. And the actual personal calendar that I want to use is this one. I click it, and you can see that it retrieved 4 items. And if you see here the title of these items, okay, and if we open up the browser with the Google Calendar, and that browser window, where is it again? Here is it, above. Okay, so now you can see that it indeed has 4 items. The green one is a different calendar. We need to look at the purple items, 4 items. And what we can do more is actually, now let's first execute it before inspecting the code. We can also programmatically insert new events. And for example, let's make some new event, hello world, and this is live from the webinar. And I pre-configured this to be scheduled at in 3 days between 2 and 6 o'clock in the afternoon. So let's create that event. And let's now go and look in the Google Calendar, and you can see that it already added here this event in my Google Calendar. So let's quickly inspect the code. But so this way you can see how you can actually use the Google Calendar component to programmatically fill items in your Google Calendar. So here I create an instance of a Google Calendar item. I set some text for the summary, some description text, a start time and an end time. Very important is the calendar ID, so the calendar in which I want this item to be added, and then I perform the function Google Calendar, add it please, and then it has performed everything for us. So this was an example using the Google Cloud Calendar. We have something almost equal for Microsoft Outlook Calendar. If your preference is to use these tools from Microsoft, that's equally possible. Let's now look at a different example. I first need to close my application. Okay. And that is the cloud storage services. So that means we deal here with storing files on the cloud. That includes Google Drive, Microsoft OneDrive, Dropbox, and Box. And in this demo application, we have offered for these 4 services. And there are a couple of functions to automatically upload, download files from these services to create new folders, open folders, etc. If I have a look at the download code, what it does is get access to the file item that is clicked in the list box, and it will then here call the cloud storage service.download method. And as you can see, this is an application that supports the 4 different cloud storage services, yet regardless of the cloud service that I'm connected with, when I call cloud storage service.download, it will perform the download of the file. And the same applies to uploading, creating folders, etc. That means that we have fully abstracted file access on these cloud storage services, regardless of what cloud service you are connected to. You will see it in a moment when we run this application. So this is my application, and I now select from the drop-down Google Drive. It has preset my client ID and secret, and I perform connect. It has already stored my previously obtained access token. That's why you do not see any authentication authorization screen here. It had that already obtained from a previous test of this application. It's persisted that access token, reused that access token was still valid, and as such, it has immediately received all the files that happen to be in my cloud, in my Google Drive account. And so if I click this file, for example, and I click download, it will automatically propose to download this file, for example, here in my documents folder. And now the nice thing is, if I change my mind and rather use Microsoft OneDrive, press connect, it will, as you can see, it now filled this list box with all the files from my OneDrive account. And with exactly the same code, I'm now working with Microsoft OneDrive, but I can use the same code to just pick here a PNG file and trigger a download to this same documents folder. And so same code, different service, everything works as expected. So this is what we offered with cloud storage services. And we offered something similar with 2 more services, that is logging and file conversion. Let's maybe first have a look at file conversion. So I mentioned that with services from Zamzar, Convert.io, and also Cloud Convert, we can create applications that change file formats of different file types. So here in this application, what we do is execute an open dialog to pick a file. In this example, we will work with audio files. And here, depending on the selection in the radio group, we set the cloud storage, the cloud format conversion service that we want to use, either Zamzar or convert.io. We also set the API key, and then we launch the file conversion. And that is launch of the file conversion, because the first step in the conversion, of course, is to upload the file. And once the file has been uploaded, the cloud conversion service can start working and will asynchronously return us the response. You can understand that this obviously will be asynchronously, because depending on the file type, the size of the file, and the complexity of conversion, it might take a variable amount of time. When it has finished, so then it triggers an event that everything is ready. And it's here that I want to bring up the form designer again. So we have this cloud conversion component. And so when the job is finished, it asynchronously triggers this event. And from there, we can say, okay, nice that it was finished. Now, please let us download this file. And this is what is happening here. I have to be careful with my mouse. Okay, that's better. So download all files to folder. I have a specific folder here specified where it will download it. So let's see how this works in action. Let's compile and run this application. And so here my key is already preset to the Zamzar service. I press convert and it allows me to pick a file. I have, for this example, prepared some audio file. And so I picked it. It is being uploaded. So you can see that the conversion started when the upload was happening. And then it triggered the event that the job is finished. Upon finishing, I forced it to download the file. And what I actually requested, that is very important, what I actually requested was, please convert this file from MP3 format to AAC format, the Apple encoded format. And so let me show you the result in the output folder. So we move to the temp folder here. And here you can see that today it has returned this file. And you can see the size here is 872 kilobytes. Let's now switch to another service. So what I do is go to my key manager. I need my convert.io key. I paste it into my edit control, select the convert.io service and pick the file again. Same MP3 file as you can see here, open it. Okay, and it starts again. You can see some differences here in response. That is because convert.io works in a slightly different way with job file names, conversion job file names. But you can see that the result, it has also some slight difference in dealing with commas, as you can see here, that it and spaces, where it uses a underscore for the commas. And you can also see that there is a slight difference in size. So the convert.io service was returning the file in a somewhat larger AAC file to prove that actually this is sound, that this is that it is a real result. So I think you can hear indeed that it is the music that we asked to convert. All right. Let's now quickly jump to our last example, which is about cloud logging, logging information on a cloud service. And in this demo, we will use the Sentry service. I will open, first of all, my control panel for the Sentry service. And it is loading my data. So this is my account from TMS Software on the Sentry service. And from this view, you can inspect everything that has been logged. So let's go back to my application. Okay, so what do we have? We have the Sentry components. And what the first step is with the Sentry component, that is, it will use the API key, of course. Everyone using that service uses an API key. And what you can see is that from the onChange event in my key edit control, I assign it to my authentication token for the Cloud Sentry service. That is what uniquely identifies my application and access to my data. That is how Sentry offers access to its service. And so the first thing that I do is get all projects, because I have 2 projects defined in my Sentry service. You can see here the 2 projects defined. And so I want to use this specific project, log everything under the TMS logger project. So what I do is first, please return all projects. And it triggers an event when it has retrieved the project on get all projects. Same here, asynchronous event. It shows me how many projects I have. And then it will simply loop over the projects found and add them to a list box, both the ID and the name of the project, and also an object that it stores with the item in the list box. It uses the add object. It will pre-select the first one. And then looking at the code, I have 2 possible uses of the Sentry logging service. The first one is simply logging a message. So let's have a look at the code. That is actually very simple. Cloud Sentry log a message, where it will, first of all, use the project I want to send it to, and that is that object that I stored with the list box for the selected item. And then the message that I sent is very simple. It is the text of my edit control. What I also did in this application is redirect all exceptions to my Sentry service. And that redirection I did set up in, let me see here, in the form on create event, where I redirect application on exception to my exception logger. Okay, and let's have a look at the implementation of the exception logger. If of course, I only want to start logging my exceptions once I'm effectively connected to a cloud service, to the Sentry service. And so when a service or a project is selected here, then I can use the call log exception. First parameter is again the projects I want to log to. And then what I log is my exception message, exception class name, the pointer of my stack info here as an hexadecimal value, and also the stack trace returned by my exception. And then I simply show the exception again, so we will not see anything else than exception logged. So let's run the application and let's see the result. So here we go. We need my key manager again to set my Sentry key. I paste it, I connect, and you can see that it found 2 projects. And we will want to log into the first project, the TMS logger one. And let's log this message, hello world, from the webinar. I do log message. And if we inspect our Sentry dashboard, we refresh it. And here is my dashboard again. And here you can see hello world from the webinar. This is the message that was logged on Sentry. Now, in the other button, I caused an exception. Let me have a look. Okay, so this is the other button that triggers an exception. What I actually do here is trying to access a listbox item and cause a listbox out of bounds, because an item with index count obviously does not exist. So that triggers an application exception. And it is that exception that we want to log on the Sentry service. So let's cause that exception. Okay, you can see we get a list index out of bounds and it says exception logged. So that bodes well that it will be successfully logged on the Sentry logging system. I do a refresh again on my Sentry page. And let's see, you can see here the string list error. So the last message that was added here 20 seconds ago. So that is the exception that was here logged into my application, in my Sentry dashboard. So it is a way to add automatic exception logging to your Delphi applications. And with that, we already exceeded the hour. So with the live coding and demos, so let's allow for a short moment of questions and answers if there are any. I'm having a look at the chat box for questions, and I see my question is, say it works with the current major cloud providers, so that's Google Drive, OneDrive. Will it be able to work with the new major cloud provider? The answer here is yes, on the condition of some work is done. If there is another popular cloud storage service provider, first thing we need to do is inspect the API that service exposes, and then actually implement the API in an on the abstract cloud storage service provider class that we have. And then it has a chance to become available as just another cloud storage service provider you can choose from. So if you, I think if you want to do it yourself, technically you can do it. It will, of course, be quite a lot of work to decipher the complete API. It gets tricky, for example, when dealing with very large files. Our cloud components offer or support that you deal with 2 gigabyte files, for example, and require some special HTTP request coding and resumable HTTP requests. And so that will require some knowledge and technical effort to implement it. But I would give the message that if you detect a convenient, affordable, good, popular cloud storage service that we have not covered yet, let us know. We will, with interest, look at the API, and when everything is feasible, it can become just another cloud storage service next to the others we already have. And I see my colleague Gjalt has also answered this specific question also directly in the chat box. Take your chance for any further questions. Otherwise, I proceed to another interesting part of this webinar, which is our offer for you. We have for this week a 20% discount offer on the FNC Cloud Pack for any new license. To obtain it, most easy way without typing anything is scan the QR code that brings you to the online order form with the discount enabled. Otherwise, you can also go to our order form, the cart items added to your cart, and then enter the coupon code Cloud23. So our Cloud9 for today is Cloud23. That is the code for getting your 20% discount on FNC Cloud Pack. I see another question here in the chat box meanwhile. S3 is a standard protocol for file services not only used by Amazon, but also as a protocol for some other free implementation. So it would be nice to support that. Yes, S3 is not your typical REST API endpoint-based protocol. It deviates from that. And indeed, it is also on our radar. It depends a little bit on the demand. So if you really want to see S3 support, let us know. And if there is sufficient interest in that, it's definitely something we will want to look into. And with that, if there are no further questions, then I want to thank you for being here. Thanks for your time, for taking out your valuable time to attend this webinar. If you have ideas for future webinars, let us know. We look forward to it, to bring you many more webinars this way. Actually, to repeat it, webinar via our TMS Web Academy platform, which is a platform that we fully built ourselves using the Eat Your Dog Food principle. We built this with TMS Web Core. That's what you have been using to attend this webinar. Thanks again for watching. The replays will become available to all registered users in advance as fast as we can. And for the rest, I wish you a further very nice day. Enjoy your day, enjoy Delphi coding, and enjoy our TMS components. And for all ideas, feedback, suggestions, be in touch. You know where to find us, either via email or via the support center. Nice day and see you the next time. Bye-bye.